Up next is David J. Malan. He's a Gordon McKay Professor of the Practice of Computer Science at Harvard University in the School of Engineering and Applied Sciences, as well as a member of the Faculty of Education in the Graduate School of Education. That's a lot of words there, but it's a very impressive title. He teaches Computer Science 50, otherwise known as CS50, which is among Harvard University's largest courses, one of Yale University's largest courses, and edX's largest MOOC with over 3.8 million registrants. That's a lot of people, certainly more people than I've ever had in my classroom. He also teaches at Harvard Business School, Harvard Law School, Harvard Extension School, and Harvard Summer School. Now, nicely, all of his courses are freely available on OpenCourseWare. Hi, David. How are you?
Good. Thank you so much, David, for having me. Nice to see everyone in the chat from all over as well.
It's nice. It's the most international gathering I think I've ever been part of. It's quite exciting. It might get a bit confusing with two Davids in the conversation, but please do direct your questions to David, and we'll assume it's all for the highlight of the session today, which is Mr. Malan here. And David, I'm going to disappear from the screen in a second so I can get the aspect ratios set up correctly. But whenever you want to get started, you'll.
Yeah, so nice to see or meet everyone. My name is David Malan. I teach this course called Computer Science 50 or CS50 at Harvard University, which is indeed freely available to take as OpenCourseWare, which means if you're a student, you can take the course freely online. You can submit the homework assignments. You can write the code. You can get automated feedback and more. And if you're a teacher, OpenCourseWare means that you're free to adopt or adapt any of CS50's curricular materials for your very own classroom. And indeed, given how international today's audience is, given how Replit is all about enabling teachers and students alike to solve problems with code, thought I would share a few of the problems that we have our own students solve with code so that you're welcome to tackle these problems on your own or even adapt them in some form for your own class. If helpful, I'm going to provide a whole bunch of URLs both in the chat and on these slides. But if you'd like to pull up the slides yourself so that you have them after today, you can go to cs50.ly/edfest22. cs50.ly/edfest22, and that way you can copy, paste, or click on all of these links directly. So just for some context, CS50 looks a little something like this in healthier times. So a few years back, before so much of the world was online, we're regathering in person in this beautiful space, Sanders Theater on campus, where we might have 700 plus students in person learning a little something about computer science. But as David notes, through edX, through YouTube, through other online platforms, do we have even more students around the world via what's called CS50X, which is the OpenCourseWare version of the class at cs50.edx.org, which means you're welcome at any time to take the course, whether unofficially or officially, through platforms like this one as well. We also, if you are a teacher in the high school or middle school space or K-12 more generally, have an offering called CS50 AP, which is an adaptation of the class for teachers that they can use in satisfaction of the College Board's AP Computer Science Principles class, or just teaching introductory computer science more generally. And if this list isn't overwhelming at a glance, we and my colleagues here at Harvard also have a whole suite of courses as well that you can take either before CS50 or even after CS50, including introductions to game development, artificial intelligence with Python, web programming, all the more on Python itself, and this whole list here. So indeed, if you have that URL from before for the slides, you can peruse this entire list and much more. And quite coincidentally, we have our own workshop this weekend. Every year, we offer professional development for teachers. And if you go to cs50.ly/register, you are welcome, if you're a teacher, to join us this weekend live via Zoom from anywhere in the world for a bit of professional development as well. So David, I came prepared with a whole bunch of visuals and sample problems that students are welcome to solve using CS50's platform, using Replit or others. Thought I would share a few of those, and then happy to take any and all questions along the way from the group here too. Feel free to chime in at any point at all. So one of the very first problems we start with in CS50 looks a little something like this, although we happen to use C in CS50 as well as a bit of Python, SQL, JavaScript, and HTML and CSS as well. So each of these problems might be specific to one language, but could certainly be adapted to any other language as well. And we invite students really in the first week of C of the class to build a little something like this using something called ASCII art. And if you're an experienced programmer yourself and you want to recreate something like this orange pyramid here, maybe using hashtags instead of anything graphical to represent those bricks, you could perhaps just do this maybe with a combination of one loop, 2 loops or more. In fact, this is an example of a problem very early on in the class that challenges students just to start to think about how you can break down something that's particularly visual and then translate it to some kind of logic, some kind of code that achieves your particular vision. At the bottom of all of these images, while I go ahead and include URLs, if they're cut off for you by my name, take a look at the chat where we'll paste it as well. And also in the slides are all of these same URLs as well. And this is then Mario. We then transition to focusing on something called algorithms. An algorithm is step-by-step instructions for solving some problem. If you're familiar with US currency, people tend to, if they're not using credit cards or something digital these days, might carry around some quarters, dimes, nickels, and pennies, which are 25, 10, 5, or 1 cents respectively. But have you ever considered if you had a drawer full of coins like this and you were a cashier working in some store, you want to minimize how many coins you're giving back to the customer, because it'd be a little obnoxious to hand them like 99 pennies and then have to carry that around. You might give some thought to what the most efficient algorithm, step-by-step process would be for handing back a customer the fewest number of coins in total. And so indeed, much like these things are lined up from left to right, it turns out if you have all of these coins in your cashier's drawer, so long as you take a big bite out of the problem first by grabbing as many quarters as makes sense, and then move on to the dimes, then move on to the nickels, then move on to the pennies, it turns out mathematically with US currency and also EU currency, will you necessarily hand the user back the appropriate amount of change minimized. Things go a little awry if you're missing one or more of these coins, but that's an example of a problem then we would translate in a course like CS50 to actual code using C or Python or some other language as well. So how about this? This is perhaps a phrase you might remember from school. 1 fish, 2 fish, red fish, blue fish. It's not particularly complicated to read. And perhaps in the chat, if you had to guess what grade level this paragraph of text is designed for, what might you say? 1st grade, 2nd grade, 3rd, 4th, 5th, all the way up? Any guesses as to what grade level a book with this kind of paragraph might be? Feel free to chime in the chat. There we go. I see Maya has proposed grade 5. So it's not bad. It's not that far off. But it turns out if you were to analyze a paragraph of text like this using code, be it in C or C++ or Python or something else, you might actually get something even lower, at least in English, namely 1st grade or 1st grade or lower. Now, why might that be? Well, if we're looking at some English sentences here, they're all pretty short. 1 fish, 2 fish, red fish, blue fish. And so that probably suggests that you don't need to know English very well. You don't need to necessarily be that old to understand a set of sentences like this. But by contrast, if we were to escalate things to this, a large class of computational problems involves the determination of properties of graphs, digraphs, integers, arrays of integers, finite families of finite sets, boolean formulas, and elements of other countable domains. Now, it's okay if you don't know some of those English words, and it's okay if you have no idea what the paragraph of text itself means, taken from an academic context. Something like this is clearly more complicated than the previous example. It's using bigger words, it's using more words, it's using longer sentences. So it turns out using various algorithms, you might conclude for a problem like this that indeed it's meant for like grade 16 or higher. So someone in high school using American nomenclature. So this too is a problem you might want to tackle or perhaps adapt in some form by writing code to analyze text like this. Well, here's a nice message from me on the screen. Whether you've taken CS50 or computer science itself, you might not recognize what this says, but this is ciphertext. This is an encrypted message of sorts. And it turns out that the message itself is pretty short, 1, 2, 3, 4, 5 letters long. You might be able to guess what the text says, but we would ideally use some code, write some program to figure out what this message actually says. And I'll spoil it by saying this message here, perhaps appropriately, says hello to all of you around the world. But why is that? Well, it looks like I've taken every letter in what we would generally in computer science call my plain text and changed each letter by 1. So if I want to say hello, H-E-L-L-O, it looks like then in this ciphertext, I've encrypted things, scrambled things by changing my H to an I, my E to an F, my L to an M and an M, and then the O, of course, to a P. So indeed, hello, as Allison notes, is exactly the original message. And that's because I've changed all of the letters in this alphabet by 1. And if you were to now decrypt or reverse this process, you of course need to know by how many letters I shifted it. So for instance, at this URL here, this is an example of a Caesar cipher, a rotational cipher used many years ago historically to actually send encrypted messages using something that humans could have done paper pencil, but you of course can now do using code. And as Emily notes, this might otherwise be called rot1 or rotate one place. Rot13 is perhaps common in sites like Reddit and the like for doing spoilers. And consider perhaps why rot26 would perhaps be a bit ridiculous to use at all when trying to encrypt information. Well, here's another problem that you might want to tackle or adapt for your own. It turns out in many countries, you, of course, have elections via ballots. And this is a piece of paper, typically, via which you write down or you check off someone's name on that ballot in order to vote for them. And suppose that you were in an election where we had these ballots for a presidential candidate or the like. It would seem that Alice got 2 votes here, and Bob got 2 votes, and Charlie got just 1 vote. So it stands to reason that we probably don't want Charlie becoming president, but between Alice and Bob, who should win? Well, we could do another election and have everyone come back and fill out yet another ballot. But what if we just asked people in advance for a bit more information, perhaps to rank their candidates from most preferred to least preferred? Maybe we could even simulate a so-called runoff election in code. And indeed, that's what we could do if we just ask humans for a bit more information. Here might be alternative ballots in this world, where someone on a piece of paper writes down 3 names or checks 3 different boxes in some way. And so now, for instance, this person at top left really prefers Alice, then Bob, then maybe Charlie for president, as does the next person. But this third person in the middle perhaps really prefers Bob, and then Alice, and then Charlie. From the looks of it, Charlie doesn't seem to be doing too well overall. But if we were to now analyze these ballots in electronic form using code, maybe we could simulate who should win this election by looking at who got the fewest votes, maybe crossing them off the list entirely, and then rerunning the algorithm to determine who's next best among all of those cast votes. So here is a problem via the URL down below, via which you too could either run an election yourself or perhaps assign it to your own students. Well, how about images? You and I all the time nowadays are sending and receiving images in the form of GIFs or JPEGs or PNGs, or more playfully in the form of memes. Well, underneath the hood, what really is an image? Well, you probably know that computers ultimately speak zeros in ones, the so-called binary system. And in fact, just using zeros and ones, you could come up with a convention for representing even images. Here, of course, is a very happy smiley face composed of black and white dots, otherwise known as pixels. Well, maybe we could just decide as a group that any white dot shall be represented with a 1, and any black dot will be represented with a 0. And as such, if we look at these zeros and ones, these bits, these binary digits all the way at left, that, for instance, could be how your Mac, your PC, your phone represents a black and white smiley face underneath the hood. Of course, you and I are familiar with more colors, and if we were to take things further, this might be a little harder to see, but if you kind of step back and look at all of these zeros and Fs that I've put on the screen here, you can perhaps see a smiley face popping out on the screen. And indeed, we've done the color coding here just so that things pop out on the screen. But in this case, we're using more than just single bits, more than just a single 0 or 1. Rather, we're now using, it would seem, 24 bits or 3 bytes, so to speak, such that FF, as you might know from the world of HTML or Photoshop, represents the color white, whereas 0000 FF in this case might represent a different color altogether. And it seems to be a little backwards here if you're familiar with RGB, but this is an example of what's called bitmap, a BMP file popularized in Windows back in the day for wallpapers that actually does hint at how computers store this information too underneath the hood. So via this filter problem set, with an understanding of how computers store zeros and ones in images ultimately, could you even implement your own TikTok or Instagram-like filters in code and morph your own images into something even prettier still? And how about this? So here on the screen seems to be a whole bunch of red noise. And if you're like me, at least growing up, you might have gotten a secret message of sorts in your cereal box or something like that. And if you just stare at it all day long, you can't necessarily make out what it says or means. But if you were to put on those like red glasses that turn everything red, there might be some secret message that comes to life in this image. And in fact, I'll do the work for us. If you and I were to write some code that simulates these red glasses, that makes everything red, that might allow some non-red color to shine through nonetheless. And so here is, for instance, this message. If you grew up playing the game Clue or Cluedo, it was Professor Plum in the lounge with the candlestick. So that was there this whole time. I'll go back. That message is there. And if you kind of look at just the right angle or with just the right glasses, you can make out what it says. But this is just an example of how now digitally we could solve problems and reveal what this message might be. This is generally an example of something called steganography, the art of hiding information in some other piece of information, as in this case. Well, what else might you do too? Well, here's an example of Alice and Bob again, not running for an election, but with a strand of their DNA. You might generally know, or if you take a biology class, you'll learn a little something about proteins and A's and T's and G's and C's. And long story short, humans are composed of these letters of the alphabet in different patterns. And that's what gives me blue eyes or brown eyes or different skin tones. And these strands of DNA can, for better or for worse, pretty much uniquely identify you and me, at least with high probability. So in this problem set here, this programming assignment at this URL down here, could you even analyze textual information like CT, AG, AT, and so forth, and figure out, does this strand of DNA belong to Alice or Bob or someone else altogether? And indeed, this is how law enforcement might actually identify suspects at a scene, by figuring out exactly who's left evidence of these strands of DNA. But that too, once digitized, even in like a simple .txt file, could you analyze with code and conclude who perhaps had been present? And then even web programming. You and I use the web every day. We're literally using it right now. But in CS50, for instance, we end this particular class by introducing students, after having learned some C and some Python, we introduce them to databases and web programming by way of JavaScript, HTML, and CSS. And here's a screenshot of something that CS50's own students build called CS50 Finance, which is like a stock trading website. We learn a little something about APIs, application programming interfaces, via which you can talk to a third-party server and get nearly real-time quotes for stocks, and then figure out how you might buy, quote unquote, or sell virtually stocks like these, like one share of Netflix here. And this screenshot I took this previous semester, I dare say if we look now, Netflix's stock is probably not at this same level. So a moment in time. Well, just to give you a sense of what else you might be able to adopt or adapt in your own classroom, or if you're a student and you just want to solve fun coding problems on your own, I thought I'd give you a final tour of another class among that list from earlier, focused specifically on Python. Though these problems, too, if you're a teacher, could certainly be adapted for most any language as well. And indeed, as David notes, if you have any questions, not just about these kinds of problems, but about computer science more generally, please do chime in the chat, and we're happy to field them along the way as we wrap up. So if you're a fan like I am of the show Seinfeld, you might remember this scene here where Kramer goes into a bank. And in this particular scene, Kramer, one of the stars of the show, is promised $100 if the staff of the bank do not greet him with a hello. Unfortunately, he doesn't get a hello. He gets something like a hi instead. And thus ensues some hilarity whereby Kramer insists on $100. The bank manager insists that he did get a hello, even though it was a hi. But it turns out they compromise and give Kramer $20 because the greeting he got started with an H. So here is some inspiration for a problem at this URL, via which you can write code to analyze how much money the bank owes someone, whether the staff says hello, hi, how are you, how's it going, or anything else. And indeed, this is one of the first problems in CS50P, CS50's Introduction to Programming with Python, via which you can focus entirely on one language and focus on solving code to come up with those values. If you've programmed before, you might have seen that sometimes letters and words in code seem to have alternating case, uppercase and lowercase. Or you might come from a world where you use underscores instead to have multiple words and some variable or function name. It turns out that you can convert one or the other if you have certain heuristics. And so picture here is a camel with a hump in the middle, and it represents what's generally in programming known as camel case, whereby generally things like variables and functions can't have spaces in them. So humans try to delineate the end of one word and the start of another by either using underscores or by changing case. So here, for instance, at this URL is a problem via which you can do that conversion from one convention to another. Here is a customized Coke bottle, and it turns out you might want to implement in code a soda machine. Back in the day, soda machines were purely mechanical, but nowadays they're increasingly digital. And indeed, you could write code to decide, once the human has inputted enough quarters or nickels or dimes or pence or whatever the unit of currency might be, whether or not to actually dispense a soda. And so here with this problem, you have an opportunity to implement really your own Coke machine at this URL here. If you've used Twitter or followed Jack Dorsey, you might know that the very first tweet in the world was supposedly this by Jack, just setting up my Twitter. And notice the absence of any vowels in the name Twitter here. And indeed, that was the original name for the site. Well, it turns out using code, you could let the human type in any sentence and then maybe get rid of all of the values just to kind of compress or shorten the text. And you and I often do this when texting or direct messaging someone just to save time. But you could certainly imagine writing code as via this problem here that allows you to compress the text that's being sent. Here, we're in Massachusetts at Harvard. You might imagine having a vanity plate, a custom license plate. But it turns out that Massachusetts and other states and countries around the world have actually pretty regimented rules. You can't come up with any old phrase on a license plate. You have to adhere to certain conventions. And so here might you write code that actually analyzes the user's input and decides, yes, that is a valid legal license plate you can have, or no, it is not. Alternatively, you might imagine in a car, taking a look at your fuel gauge like this, which is often presented as fractions or maybe as percents. But in the world of fractions, you might see a quarter tank, a half a tank, 3/4 of the tank, or somewhere in between. Well, it would be nice to actually digitize this and convert these values, especially when you're running low with empty or full, to actually tell the user digitally on the car's display that they're low or full on gas. So in this problem here, do you have an opportunity to convert really fractions, which are really just text that the human has typed in, converting it instead to something like a number or E or F in this case. Alternatively, if you're actually local to Massachusetts and specifically Cambridge, where Harvard is based, there's this really popular Mexican place around the corner from us called Felipe's. And they have a menu via which they associate all of the items on their menu, be it a taco or a quesadilla or the like, with the current price thereof. Well, it turns out that one way you could represent something like a restaurant menu is using something called a dictionary or a hash table more generally. It turns out languages like Python have built-in support for that feature, so you can actually implement not just this restaurant, but any other using code like we'll show you here. And then just a few others come to mind that I thought would be fun to share. This is a toy I myself grew up with. Funny enough, it was called Little Professor, and Little Professor allows you to actually solve mathematical formulas that are randomly generated on the screen. When the battery's installed and you turn it on, you'll see a little LED display that shows you math formulas that are up to you to solve. Well, it turns out if you're a little older now and can write code, you can write a program that solves all of Little Professor's problems for you, as we'll challenge you to do in this problem here. Bitcoin, of course, and Ethereum and other cryptocurrencies have been all of the rage, although perhaps a little less so now. But it turns out there are third-party APIs that you can talk to, servers remotely, and get actual prices of coins like Bitcoin itself. So in this problem here in CS50P, might you have an opportunity to do just that, make something a little interactive to figure out, for better or for worse, what's the current price of this coin or this other. Now here at Harvard, we have this tradition of giving out T-shirts that say, I took CS50 at the end of the class. Well, it turns out when you know a bit of programming, you can make your own digital version thereof. And in this problem set, what we challenge students to do is to take a default image like this and then figure out how to take a photo of themselves and impose this shirt on that face. And I can't quite do it here with typical PowerPoint slides, but essentially, we challenge students to do a little something like this. My body would actually be behind or in the shirt virtually, but the goal is to sort of line up the human's head in just the right way so it kind of sort of looks like they're wearing that virtual shirt. Many of you might have used Google Forms or Microsoft's equivalent thereof. Well, it turns out there's these little check boxes or toggles via which you can specify that this input by the human must be an email address or must generally fit some pattern. Those patterns are called regular expressions. And it turns out in Python, you have a lot of built-in functionality that allow you to detect patterns in users' input. So you can check to make sure they typed in a valid email address or that their response is short enough or long enough per some requirements. And so we introduce students to these things called regular expressions, which isn't even specific to Python, but exists in languages like JavaScript, C++, and others, and beyond. And then lastly, in our case, we offer students a full-fledged digital shirt in the form of a PDF that they can programmatically generate. Our own PDFs are called CS50 certificates, but for this problem set, students implement their own CS50 certificates, whereby we challenge them to write code that actually puts their own name, whether John Harvard or something else, digitally on that same t-shirt. No face this time, but generate a PDF that they can actually hang on to. So these are just some of the problems that we assign to students here in Cambridge or students around the world via CS50X. Even if you've never taken CS50, you're welcome to just sign up to tackle one or more of these problems just for fun. And again, indeed, if you're a teacher yourself, by all means, feel free to adopt or adapt these materials or others, weave them into your own classrooms in your own style. And again, please feel free to join us this coming weekend for CS50's own workshop on all this and more. Happy to take any and all questions, David, from the group here as well.
Great, fantastic. We've got some brilliant questions coming up in the Q&A section, but I can't quite put them on the screen at the moment, so I'm going to read them to you, David, if that's okay.
Sure.
So the first one I think is quite an interesting one, and this is from Omar. He says, at what point in your life did it tick with you that you love CS, not just the teaching, but CS in general?
That's a really good question. So as CS, for me, it clicked in college. I was a sophomore, so a second year in university, and I actually took this same class that I now teach, CS50. And truly, it was the very first time I'd taken a class, probably in 18 plus years, that I loved taking. And I would literally look forward to going home to my dorm room, Friday nights no less, downloading the new homework assignment for the coming week, and starting on that homework. And so if you get excited at 8 p.m. on a Friday night to do your homework, like for me, that felt like a sign. And I switched my majors at the time from government, which I had been, over to computer science. And with that said, I didn't love all aspects of computer science. There were definitely courses I struggled in and material I liked better than others. But ultimately, it meant something to me that after 18 plus years of working hard in school because I was supposed to working hard in the class because I wanted to, like that was the sign for me. And perhaps that's the same for you with computer science or any other field you might learn.
Brilliant. I like that. I like that very much. Friday night doing the homework is always a good thing. I don't know which topics you found particularly dispiriting when you were at university, but for me, it was compiler design. That was a slog to get through. I think it's important that people know that not everything in your subject domain is going to be your favorite thing as well.
Indeed.
So I've got another question here from Sean, which is interesting about the way you teach. What is your rationale for teaching so many different programming languages in an introductory course? Do you think there are advantages to this approach in a high school CS course as well?
It's a really good question. And for those less familiar, I noted earlier that we introduced students actually initially to Scratch for just 1 week, then several weeks on C, then a few weeks on Python plus SQL, JavaScript, and then HTML and CSS. And all of those languages, 5 of them programming languages, don't even fit on one hand, admittedly. So it's for 2 reasons. One, for many students, half in our case at Harvard, CS50 is a terminal class. It's the one and only computer science and in turn programming class that they're going to take. And we do very much want them to have not only a conceptual lay of the land, like what computer science is, how you solve problems with code, but we want them to have sufficiently many practical skills so that they can now take that new mental model, that new understanding of computer science and apply it to real world problems in their own domains, whether it's the arts, the sciences, humanities, social sciences, or beyond. For the other half of students, CS50 is meant to be a foundation in computer science, whereby it's just one of many courses they might take. And so we are continually trying to expose students to a range of material too, so that they, like me back in the day, can sort of figure out what they like. And I think philosophically too, back in the day when I took CS50, it was only taught in C. It was many, many more weeks than we now have in C specifically. And I, like a lot of my classmates, loved the material, even loved the language, admittedly, but felt like we had taken a course in C. And we would tell people that, oh, I took a course in C. I know how to program in C. And I didn't really want that to be the learning outcome for our students nowadays. I wanted the vernacular to be, I learned how to program, period, or I know now how to program, period, and not scoping it to one language in particular. So it is a lot. It is a fire hose of sorts. The advantage, though, of taking the class online is that you don't have to fit it all in into just 12 weeks. You can take 52 weeks or even more.
Thanks for that. That's great. With the high school thing in mind, though, and I'm talking from an international point of view now. Certainly in the UK, we have our languages mandated for us at high school level. Do you think there's still merit in pushing out into other languages, even though they're not assessed formally?
Short answer, yes. I just think it's all the more empowering when you really have a bottom-up understanding of programming and you start to see patterns across programming languages, because I think it's all too easy otherwise to start focusing on the wrong things, the stupid curly braces and semicolons and parentheses that are necessary in some languages but are completely uninteresting intellectually and are just distractions to getting real work done. It's important to master those things ultimately, but when you're learning how to program, it really is the ideas, the functions, the loops, the conditionals, the variables, and like the building blocks that are important that you even see in graphical languages like Scratch. So I would like to think actually that this broader exposure in your first or second experience programming actually helps make you a better programmer in other contexts too. And I do think too, at least in the US, far too many courses in computer science and programming are so unduly focused on the language itself. And it's just not interesting to learn one particular language when really you're trying to learn that language to solve actual problems.
Fantastic. Thank you. Another question here from Vladimir. In your opinion, is there any physical computing kit, bots, buggies, robots, that actually helps teach CS concepts to children aged 8 to 15 or coding in general? Do you have any recommendations for physical things?
It's a good question. Very few, because we've generally shied away from hardware here, at least because of the cost involved, because of the inaccessibility for students online to then have to order something or pay even more based on exchange rates. So I'll qualify this by saying we've generally not used hardware so much in my own courses here. I will say over the table right over there, do we have some Lego Spike kits that do actually allow you to program using a graphical language like Scratch, or even something lower level like Python nowadays, that we're just starting to experiment with. So if you ask the same question in about 7 weeks, I can tell you how the very first or second lecture of CS50 goes, because we're going to try using this same Lego hardware in class most likely this fall. But we'll see how it goes. With that said, Raspberry Pis are certainly quite popular. Other similarly small devices, the barrier to entry really tends to be the cost, I think. So we've generally, in my case, focused on software and the computers that the schools or the students already have.
Fantastic. So a few questions about CS50 and assessment now. After finishing the CS50 PSETs, what would you do? Sorry, what would you suggest to find problems that they can solve themselves and practice those skills? Where would you suggest they go, and what would you suggest they find to improve those skills?
A really good question. There are a lot of websites out there, Replit among them, that have repositories of problems you can solve, but you'd be solving them for the sake of practice as opposed to solving some problem of intrinsic interest to you. And so I think after you've learned a bit of programming by taking 1 class, 2 classes, be it in person or online or on your own, I think it's best to try to find a personal project of interest. Like, say yes to building something that you have no idea how to build. So that you have to ask your teachers, your friends, folks on Discord, on Reddit, on other communities, questions frequently, trolling Stack Overflow, looking for ingredients that you can then leverage as solutions into your own problems. I think that if you find some project that's not someone like me or someone else has written up for you to assign you, but rather some project that you just want to get working for its own sake, I think you'll end up learning much more, and you'll find yourself intellectually going down many more rabbit holes, so to speak, trying to better understand, why does my code now work? Because it's your code now. It's not for some assignment. It's not for some practice problem. It's something you want to use for yourself, for your friends, or for the world. So find some personal project of interest if you can.
And another one from Tony. She says, what do you think is the secret to CS50 being such a popular course? What are your tips to help teachers potentially increase the overall uptake of computer science in their school?
Yeah, it's a good question. And those of you who have taken the class might have better thoughts than I. I do think that we have genuinely, in the past several years, tried to make sure that all of the problems we are assigning on our end in this introductory course are inspired by some real world domain. They're not just rudimentary exercises involving loops and make your own function or the like. Generally speaking, and even as per the visuals I offered up here today, we try to pick some real world problem that we've seen or some Seinfeld episode that we've watched, and then try to find the germ of an idea that we can pivot off of and have you build something of interest. So I think finding those pivot points where you can take something real world and then turn it into a problem involving code really helps engage many students, I think, as opposed to it being the more traditional end of chapter textbook problem that are just all too mind-numbing typically, because it's about, again, the code and not the problem you're solving. I think second, there's an unusual community aspect to CS50, both on campus and off campus, whereby on campus we have, in healthy times, a number of traditions. We have a CS50 puzzle day at the beginning of the semester where students solve logic problems collaboratively. We have an overnight hackathon toward the end of the semester where students gather for 12 plus hours to work on their capstone final projects. We have a CS50 fair at the very end of the semester where students stand up at laptops like this and present their final projects to dozens, hundreds, thousands of students, faculty, and staff from across campus. We take photos of everything where students opt in and share videos that the students themselves have made and really try to make students feel like part of something special, this collective shared experience. And I think if you can create that kind of culture, even within your classroom, and then allow others outside of that class a look in, as by holding a similar fair, so to speak, in the cafeteria, so that the non-computer scientist students take an interest in what their CS friends are doing, I think that's a great way to get a really good feedback loop and community going, as opposed to just making students take some material, but rather whet their appetite and invite them all in.
Brilliant. I really love that idea of the science fair type thing. I would love to be doing that. That sounds amazing. Big question from Eric here, but any suggestions on adapting the CS50 materials for slightly younger students, so 6th to 8th grade?
A really good question. Scratch, hands down, is a fantastic tool, and there's even a younger version of it called Scratch Junior, if you have an even younger audience than that. Now that CS50P exists, it is focused on one language, which is probably a good thing for many teachers, because then you can stay in your own comfort zone if you already know something or are willing to learn something like Python. The problems are a little more bite-sized, and I rattled off just a few of them at the end of today's slides that give you a sense of not just Seinfeld, but the others that tend to be relatively fewer problems to solve in order to accomplish that particular goal. But there's more problems each week in that class, so it allows students to make more incremental progress. So for a younger audience, I might actually start with something like CS50P, which really is about programming. And then once you feel you as the teacher or they as the students have their footing, then something like CS50 or a more general introduction to computer science, I think, is perfectly reasonable. With that said, we've had students of all ages, but now that CS50P exists, I think it sort of gives you a nice entry point that changes the slope a bit from beginner to intermediate to advanced that might make it all the more accessible to more students.
Brilliant. I've got 2 more for you, so I'll start with this one. And I think this is a feeling that we probably know well from our learners. Omar says, as free content for learning CS is getting more available, it gets very overwhelming to a beginner about where to begin, which courses to take, which track to choose. What piece of advice would you give to tackle this problem?
It's a good question. I think there's a lot of good communities to ask advice, or honestly just search through for past advice. On Reddit, there's a Learn Programming subreddit, and there's similar subreddits that focus really on that same question. So I would look there and just kind of skim these things and look for patterns, like what courses, what websites are being frequently mentioned, and maybe start there, as opposed to just starting with Google and figuring out what the internet tells you otherwise to do more generically. And I think, too, it's fine to and good to teach yourself to learn by taking these courses, working on these practice problems as before. But again, I would, as quickly as you can, find some personal project of interest, and don't get stuck all too much in this tutorial loop where all you're doing is practice, 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 or looking for yet another website to practice. Again, find some some problem you can solve for yourself, for your family, for a student group if you're in university or K-12, so that other people can use your own code. Or better still, if there's some library, third-party code someone else wrote that you've used before in your own programs, but there's a bug in it or there's a missing feature, maybe get involved in the open source community on GitHub or GitLab or the like, find the repository, the folder online which that code lives in, and then maybe just ask a question of that group, open an issue, so to speak, open a pull request, which means you propose code to it too. I think just find things where you're not stuck in this tutorial loop after 1 or 2 classes, but again, find projects, open source communities, or just goals of your own if you can.
Brilliant. And the final question, which is mainly for you, and it's from Prasan. It is, from where do you get your motivation to do this every single year?
It's a good question. I think CS50 in particular is being constantly reinvented. This will be the 16th year I'm teaching it here, and it really looks rather different than it did 15 years ago, let alone 5 years ago. Part of that is because technology is evolving, and we too, therefore, are evolving the class so that students are abreast of new trends, new conventions, and the like. But part of it too is that we are continually reinventing the course's problem sets or programming assignments. I work with some amazing colleagues here who are constantly incubating new ideas, and indeed, one of our projects this summer is to propose and discuss exactly new problems that we can introduce to the course so as to keep things fresh. And I think too, the fact that we have not just these on-campus communities here at Harvard, at Yale, and elsewhere, but these online communities as well. Students are always finding bugs that we can now fix. They're asking questions we might not have heard before. And so there's an operational challenge and a scaling challenge and an accessibility goal that really keeps things interesting and I think much more mission-driven. And indeed, I began by mentioning OpenCourseWare, and happy to end on exactly that note. I think there's just so much good that universities and teachers at all levels can do by just sharing more of their resources, more of their ideas, more of their curricular resources. And so I think in that sense for us, it hasn't just been about teaching the class from start to finish, but really building these communities, figuring out what others might need of us so that we can help uplift other communities, help save teachers time, help them focus their most precious resource on the human aspect of helping people learn. I think the more universities and schools and teachers that are in a position to do that, I think the better off all of us are when it comes to learning the same.
David, thank you so much for speaking to us today. It's been a really, really exciting and engaging talk, and I feel quite motivated to do something cool now with it. And some of the ideas you've given us today, I think particularly the way you construct problems for CS50 have given me a lot of food for thought. So thank you so much for taking the time.
Thank you so much for having me. And so nice to meet everyone via the chat here. Please feel free to reach out via email or any of the URLs that we've shared.